Hello everyone, let's talk about logarithms. We're going to use two very commonly used log bases, talk about those. The first one is if you have a logarithm with base 10, that's just called the common logarithm. If you look on your calculator, you will often see just a log button. That's the only button you have is just log. That means that the default base for logarithms is base 10. There are ways to get other bases, but doesn't matter, we don't need them right now. So don't try and find them so then you don't need to do any of the work in your head and then you can't do logarithms. You have to understand what logarithms are before we start to use the calculator problem. So the base 10 log of 10, wait a minute. What this is saying is if it helps you to kind of visualize this, because it just doesn't have a base, that's like saying 10 to the x equals 10. Oh, x is 1. For these problems, you can essentially just count the zeros. 10 to the what is 100? 2. Wait a minute. 1/10, so that's 1 over 10. So that'd be 10 to the negative first. 10 to the negative first is 1/10. Now wait a minute. 109 and 50 I know are not powers of 10. So these are going to be decimals. You need a calculator for this. I know that if it was 2, it'd be 100, so 109 is a little bit bigger than 2. The log of 109 is going to be a little bit bigger than 2. You can use a calculator and actually figure it out. The log of 109 is 2.04, 2.037. Now, when you see the log of 50, to estimate that's a little trickier. You're like, well, 10 to the power of, is it 1/2? Is 10 to the power of 1/2 50? No, it doesn't really work that way. If we do the log of 50, we're going to see it's 1.6989. So those are both decimals that you need a calculator for. But this guy's not. That's a 3. 10 to the third is 1,000. Okay, and you can check them. If you're using your calculator to do logarithms, before you know how to do logarithms, you're going to fail logarithms. Like, full stop. All right, let's try the next section here. Natural logarithm. The other base is the natural logarithm. So if you ever see ln, that's like writing the base e log. If it helps you to write it that way, you can, but hopefully you kind of get used to it. This is the base e log of e to the 8th. So if I write a little x there, it's like e to the x equals e to the 8th. Oh, the x must be 8. The natural log cancels out the e, and you just get the exponent of 8. What if it's the natural log of 1 over e squared? So probably for these problems, it's going to make the most sense to rewrite that. So I'm going to write it as the natural log of 1 over, oops, not 1 over. I'm going to write it as the natural log of e to the negative second. Because when it's squared in the denominator, that means e to the negative second. And if that helps you, then you can say, oh, this is e to the x equals e to the negative second. That must mean x is negative 2. E to the what is 5? I don't know. E is like 2.71. This is going to be a decimal. Again, you would need a calculator for this, which is kind of not the point of what we're doing right now, but I'll type in the natural log of 5 because I can't do it without a calculator. 1.609. Okay, so x is 1.609. Again, that's the question. And I'm like, not as important because I need a calculator, like these two. Can't really do them without a calculator. Not where I'm trying to be. These are interest problems, and we will use a calculator for these, obviously. And it's just saying if you want to double your money, if you want to figure out how long it takes to double your money, it's really easy to do. You just got to tell me the interest rate. If it's at 6%, I would do the natural log of 0.06. And that'll tell me natural log of 2 divided by 0.06. So the natural log of 2 divided by, oops, got to close those parentheses, divided by 0.06 will be 11.55. So if you're getting 2% interest, it'll take you 11.55. Those are years. If you do it with 0.07 to double your money, it takes 9.9 years. Now, that's 1% interest rate, but notice how it took a year and a half less. Okay, let's do it with 8. If it's 8%, you double your money in 8.6 years. So we're saving almost 3 years with 2 percentage points. Think about that when you start talking about a mortgage that's for 30 years. Like a 1% interest rate can be a really big deal. So definitely want to do the math on those sorts of things. I'm going to go through some practice problems real quick. Some of these are easy. Some of them are going to require a little bit of work. So let's go ahead and do the first couple here. I'm going to write it as an exponent. 5 to the y equals 25. What would that be? 2. 5 squared is 25. 3 to the y is 1. 3 to the what is 1? 3 to the 0. Anything to the 0 power is 1. The log of 1 is always going to be 0. It doesn't matter what base you use. 16 to the y is 4. Wait a minute. That's a y, right? It looks kind of like a 4. The square root of 16 is 4. But I'm going to show you another way of doing these problems, even if you can't figure that out, or they're fractional exponents. I'm going to write these both as powers of 2. And I know that 16 is the power of 4, but I'm going to write them as powers of 2. This is 2 to the 4th. 16 is 2 to the 4th. And now I'll say that's 2 to the 4y. And this is 2 squared. 4 is 2 squared. Now I'm going to set their exponents equal. 4y equals 2. And then I will divide both sides by 4. And you get 2 over 4, which is 1 half. Y is 1 half. That's like saying 16 to the 1 half power is 4. And hopefully you remember that's the square root. 1 half power is the square root of 16. So maybe you can do that in your head. But this rewriting the base thing is going to be something we're going to need even maybe in the next problem. Let's try this one. 2 to the y equals 1 over 8. Well, 2 to the y equals, that's 2 cubed in the denominator. So 2 to the y equals, if it's 2 cubed in the denominator, then I can write that as 2 to the negative third in the numerator, which means y equals negative third. Got out of the way. There you go. Y equals negative 3. Okay, let's keep going. 3 to the what is 1? I'm just saying this equals x. 0. 4 to the what equals 4. Oops, that should be an x. 4 to the what? I don't know. Equals 4. 1. Let's say this. This is weird. 7 to the x equals 7 to the third, so x equals 3. Now, when you see a base b logarithm and a base b exponent, those cancel each other out. You just get the argument. This is 3. Those cancel each other out. You just get 3. You're taking an exponent to a logarithm. Those are inverses. So you just get the argument, which is 3. This one's going to be a little trickier, so I'm going to write this down here. 25 to the something equals 5 to the third. So you're like, well, 25 and 5 are both powers of 5. I could write this as 5 squared. So 25 is 5 squared to the x, so 5 to the 2x equals 5 to the third. And then you can say, oh, 2x must equal 3. So x must equal, divide both sides by 2, 3 halves. X equals 3 halves. So that means take the square root and then cube it. The square root of 25 is 5, and then you cube it, and you get your 125. All right, let's see. How are we going to do this one? I think the best way to do this is to simplify this first. The base 4 log of 8. I'm going to do that first, and then I'll deal with this 16 thing. So the base 4 log of 8 is like saying 4 to the x equals 8. And then you're like, well, 4 isn't or 8's not a power of 4, so let's rewrite these as powers of 2. So 2x has to be 3, which means x equals 3 halves again. Now that I know that, I can say, what's 16 to the 3 halves? And that's one that hopefully you remember. To do that, you first take the square root of 16 and then you cube it. The square root of 16 is 4. 4 cubed is 64. So this equals 64. And I'm going to check that because this is so weird. So this is the base 4 log. I got to go to that. Where is it? I don't even know how to find log base. It's in here somewhere, I think. Ah. The base 4 log of 8. 64. Let's go. So that's a weird one, but the best strategy there is to simplify the exponent first. All right, exponential form. All we're doing is rewriting these. There's not even anything to solve for the first few. 3 to the 4th equals 81. That's true. 3 to the 4th is 81. 7 to the 1st is 7. 7 to the 1st is 7. Yeah. 1 half to the 3rd is 1/8. Yeah. 1 cubed is 1. 2 cubed is 8. Okay. 3 to the 0 is 1. All right, cool. 4 to the negative 3rd is 1 over 64. That's because this is 1 over 4 to the 3rd. So yeah, that's true. 6 to the negative 2nd is 1 over 36. Again, because that's 1 over 6 squared, which does equal 1 over 36. X to the z equals y. You can't solve that. And m to the 1/2 equals n. Or another way of saying that is n is the square root of m. And last thing, we've got write them in log form. So we'll say the the trick to these is the base of the exponent is the base of the logarithm. So 8, it's a base 8 log. 8 to the second power is 64. If it's a base 10 log, I'm not going to have to write the 10 because that's implied. It's the common log. So I'm just going to say the log of 10 to the third is, wait a minute. No, it's not. This is just wrong. Let's make this, there's too many zeros there. There. The log of 1,000 is 3. Count the number of zeros. There's 3 zeros, so the log of 1,000 is 3. So that's just wrong. 4 to the negative second. So the base 4 log of negative 2 is 1 over 16. Because 4 to the negative second is 1 over 4 squared. Okay? The base 3 log of negative 4 is 1 over 81. Because 3 to the negative fourth is 1 over 3 to the fourth, which is 1 over 81. Sweet. So that's what I'm trying to do. So by far, the most important thing for you to be successful with logarithms is that you are able to quickly go between logs and exponents. If you can do that, then everything else is going to fall into place. But you have to understand the relationship between logs and exponents, and you need to be able to do those in your head without a calculator. So if you got all that done, make sure you hit that like and subscribe button.